This lesson is on the log laws, and just like we have the index laws and how logarithms are a different way of writing an indice, we can get these log laws, and we're going to derive the log laws from the index laws. So if we say let x equal a to the power of m, and we'll let y equal a to the power of n, then rewriting both of these indices in log form, we'll have the log base a, because remember a is the base here. So log base a, and then it'll be a to the power of m equals x. So it's log of x base a equals m. And then we'll also have log of y base a equals n. Alright, so deriving this first log law here. If we were to take the product of x and y, then using our index laws, that's a to the power of m times a to the power of n. If remember we let x equal a to the power of m and y equal a to the power of n. Now you know that when you multiply indices with the same base, you keep the base the same and you add the powers, which is what we're going to do. So we're going to keep the base the same and we will add our powers there. Now changing this from index form, so this is index form here, to log form, we can then have log base a, because we have our base a, and it's to the power of m plus n equals xy. So this is really saying log of xy base a equals m plus n. So going from index form to log form using the circle, a to the power of m plus n equals xy. Now remember, m equals log of x base a. So substitute that in for m, log of x base a, and n is equal to log of y base a. So that is log of y base a. And there we have the first log law, just there. There it is there. So this is saying the log of x plus the log of y, if you're adding two logs together and they have the same base, that's equal to the log of the same base of the product of x and y. Okay, let's derive now the next log law, and we're going to use these same things here. We're going to let x equal a to the power of m and y equal a to the power of n, and therefore there they are in log form. So index form, log form, and now we're going to derive the second log law from the index laws. So we are going to say y. Okay, so x divided by y. Now remember, x was a to the power of m and y was a to the power of n. And you know that when you are dividing indices with the same base, we have the same base, the base is a, we subtract the powers. Now let's change this from, and this we'll write the x over y again here. Let's change this from index form to log form. So this is our log of a, base a, and we will write it like this. Notice the way that I wrote it was a to the power of m minus n equals x over y. Now, what does m equal and what does n equal? Well, remember back on the previous page that m was equal to the log of x base a, and n is equal to the log of y base a. So there's our second log law. We can say that when you're subtracting two logs with the same base, log of x minus log of y, that's equal to log of the same base of x divided by y. So the log of x over y with base a. And this is the third log law here. And the way that we're going to derive that is using our index laws with our powers of powers. So this time, if just say we have x to the power of r, then remember x is equal to a to the power of m. So that's the same as a to the power of m to the power of r. So we're just replacing this x with a to the power of m, because remember we let x equal a to the power of m on the previous page. So we can say that is equal to a to the power of mr, because our index laws, powers of powers, means you multiply those two powers together. All right, let's change from index law to log form. Index form to log form. So we got log and we got our base a there. And so it is a to the power of mr equals r. So just going a to the power of mr equals, oh sorry, that should be an x to the r. Let me just write that bit again. So a to the power of mr equals x to the r, and there we have it. We're changing from index form to log form. And then mr, what does m equal? Well, remember back here when we said, on the first page, when we said x is equal to a to the power of m, and then we said changing that from index form to log form, and we said then that m was equal to log of x base a. So there's m, and then you times that by that r there, and if we just put the r in front, change the order of the multiplication, we get our third log law there. So we are saying the log base a of x to the r is equal to r times the log of x base a. So really you can see that we're bringing that power down to the front of the log. That's the easiest way of remembering this third log law. And that was the proof using the powers of powers index law. So let's have a look at a couple of examples. These index laws, using these log laws to simplify some log expressions. All right, simplify log of 2 base 6 plus log of 3 base 6. Now, because they're both 6, that means base 6, we can use the log law, the first log law, to say that is equal to the log of 2 times 3 base 6, which means 2 times 3 is 6, so we've got the log of 6 base 6. And you know from one of the special results that we got that 6 to the power of 1 equals 6, so that means log of 6 base 6 equals 1. Log of anything, log of a base a equals 1. All right, the second example, write 2 log x plus 3 log y is a simple log. So we can bring this number, the coefficient of the log, to the power. That was that third log law there. So 2 log x is the same as log of x squared. Likewise, we can bring this 3 from the front and make it a power. So that becomes 3 log y becomes log of y cubed. And it doesn't say what the base is, so that means it is base e. And say they both got the same base there, so that means we can multiply those logs there together like that, and then it'd be nicer just to write it without the multiplication sign. So log of x squared y cubed is our simple log. Alright, now this is a common exam type of question. You're given the value of two logs with bases that you can't find on your calculator, and you're asked to find the value of these other logs. So the trick with this is to see how you can get 12 from 4 and 3. And well, you know that 4 times 3 is 12, so that means we can use the first log law for that one. Okay, and then the second one here we've got 0.75. 0.75 is the same as 3/4 or 3 over 4. 3 over 4. So we can use the second log law for that. 9 is 3 squared. There's our 3. 3 squared means we could bring the 2 down the front and it'd be 2 times that. 20 is 4 times 5. You can use this little base here as well as a hint to something that can help you. So log of 4 times 5, log of 4, and then plus the log of 5, and you know log of 5 base 5. Well, we'll come to that in a second because you know what that is. All right, so let's do the first question here. Log of 12 base 5. So that's the same as log of 4 plus the log of 3, because 4 times 3 is 12, using that first log law. Now log of 4 is equal to 0.86, and log of 3 base 5 is equal to 0.68. So they were both of the numbers that were given to us in the question. and just putting in your calculator, you get 1.54. So that's the log of 12 base 5. So we'll call that one A. Okay, let's have a look at B. The log base 5 of 0.75 is the same as the log base 5 of 3/4, which is the same as the log of 3 base 5 minus the log of 4 base 5. Log of 3 base 5 is up here, 0.68, minus log of 4 base 5 is up here in the question as well, 0.86. So 0.68 minus 0.86 is negative 0.18. Okay, C, the log of 9 base 5. Alright, so I mentioned before that 9 is 3 squared, so we can write it like this. And then, using the third log law, we can bring that power down the front, so that's the same as 2 log 3 base 5. So 2 times log of 3 base 5 is here again, and that's 0.68. So 2 times 0.68 is 1.36. Okay, and the last question there, 20, I mentioned was 4 times 5. So we can rewrite log of 20 base 5 as log of 4 base 5 plus the log of 5 base 5. So remember, these log laws only work if you have the same base, just like how the index laws only work when you have the same base. So log of 4 base 5, that's given to us in the question, that's 0.86. And log of 5 base 5, you know that's 1, because 5, changing from log form to index form, 5 to the power of 1 equals 5. Alright, so there we have the answer of 1.86. Okay, let's have a look at evaluate log of 5,000 base 10 if log of 5 base 10 is 0.699. Okay, so let's change. Let's see what multiples we can change 5,000 into of 5 there. And can you see how 5 times 1,000 is 5,000? And we can rewrite 1,000 as 10 cubed. Isn't that handy? 5 times 10 cubed is 5,000. And then you can see, using the first log law, that's the same as log of 5 base 10 plus the log of 10 cubed base 10. Alright, log of 5 base 10 is given to us in the question, 0.699. And we can use the third log law to bring the power down the front of this log. So that becomes 3 log 10 base 10. And you know that log 10 base 10 is equal to 1. So times by 3 is 3. So we have 0.699 plus 3. I'll just put a times 1 in there, which is going to be 3.699. Given 2 base A equals 0.3010 and log of 3 base A is 0.4771, find the value of log of 12 base A. So notice that to use these log laws, we don't even really need to know what this base is, base A. Who knows what it is? It doesn't matter, because we just want to rearrange 12 into a multiple of some kind of 2 and 3. Well, you know that 4 times 3 is 12, and 4 is 2 squared. So let's change log of 12 base A into the log of 2 squared times 3. Using the first log law, then we have the log of 2 squared base A plus the log of 3 base A. And using the third index law, we can bring that power down the front of the log on that first one, just like that. And then we can substitute the numbers in that are given to us, because we are given that log of 2 base A is here, 0.3010. And log of 3 base A is 0.4771. and that equals 1.0791. So common exam style questions.